This is a video on 4.3.1 where we're going to review right triangle trigonometry. So this is stuff that you've already seen before, but we're going to take a look at this and how it relates to our class. So the first thing you need to know is there's going to be multiple definitions of sine, cosine, and tangent. So on your note sheet, we're simply going to do the right triangle definitions. So it's a top third of that big box there, because we're going to define these functions, these values, three different ways. So be sure to leave plenty of space for all three definitions. So first of all, sine. Right triangle definition of sine, as you know, is that it's the opposite side over the hypotenuse. So when we're looking at this picture here, we'll label them O and H, and sine is the opposite side, so across from the angle, and the hypotenuse, remember, which is always the side across from the right angle. The next one, cosine. Cosine is the adjacent side. Adjacent means next to, so the leg of the right triangle that is next to the triangle, next to the angle, and the hypotenuse again. So A over H. So A, of course, next to the angle, and then the hypotenuse is always the longest side across from the right angle. And last but not least, tangent. Tangent is the ratio between the opposite and the adjacent side. So remember, all of these sides are related to where the angle is. So it matters where the angle is for every single one of these. Now, one quick way to remember all of these is by using the mnemonic device, SOHCAHTOA. So because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. So that's a quick way to memorize these three ratios, and so you can use them throughout your different math courses that you'll use and the ACTs that you'll take to get into college. Now, the next thing that we're going to talk about is new trigonometric functions. So there's three new trig functions we're going to be using in this course, and you'll be using in calculus as well. They are cosecant, secant, and cotangent. Cosecant is simply the reciprocal of sine. So all we do is we flip sine upside down, and we're going to look now hypotenuse over opposite. So cosecant and sine are reciprocals of one another. Secant is very similar in that way. Secant is now the reciprocal of cosine. So hypotenuse over adjacent. And last but not least, cotangent. Now that one, of course, is the reciprocal of tangent. So it's just adjacent over opposite. So these three you'll have to get memorized, but they are completely related. One quick way that I remember them is that cosecant and sine get matched together, so you'll never match the S's together or the C's together. For instance, cosine and cosecant will never be linked. They always have a C function and a S function. That's kind of how I remember it. So cosecant and sine are linked, cosine and secant, and tangent and cotangent. So now let's just review real quick what this means. So if we're finding the value of each of the 6 trigonometric functions of theta, we would simply look at sine of theta, and we would look at the triangle. We'd find the opposite over the hypotenuse. Notice that they didn't give us the a value, so let's go about finding the a value by using the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. Remember, c is always your hypotenuse. So a squared plus 4 squared equals 2 square root of 5 squared, because that was the hypotenuse. Now we'll simply calculate these things out. 2 square root of 5 squared, I'm going to kind of show my work for that by multiplying the number by itself and then rearranging, because 2 times 2 can be multiplied, square root of 5 times square root of 5. Since the square root of 5 times 5 is 25, it's simply 5. So I end up getting 4 times 5, which is 20. That's c squared. So I'm going to put that back in my equation and continue solving. And I get a equal to 2. Now oftentimes we consider the negative value whenever we square root both sides, but in this case it doesn't make sense because we're working with a triangle. So a will of course be positive. So now I'll plug that 2 back into my sine function. I see the answer is 1 over square root of 5, but that's improper, so I want to make sure I make that proper like we talked about at the beginning of the school year. So I multiply top and bottom by the square root of 5 to get the square root of 5 over 5 as my result. So that's the sine of theta. Now, of course, I have to find, I'm going to find its function, the reciprocal function, by flipping the fraction for sine upside down, and I'm going to take my original answer, mostly because now I see the square root of 5 is on top. So remember, cosecant is the reciprocal of sine, so that's why I flipped that upside down. And now I'm going to simplify. Cosecant is the square root of 5. And continuing on, now we'll find the cosine function, which is the adjacent side, 4, and the hypotenuse, 2 square roots of 5. Again, I'm going to simplify and make it proper. So I know I'm going fast through this, but really it shouldn't be. It should be mostly a review with a little bit of reminders about the rationalizing the denominator, so making the denominator not have a square root. Of course, secant is the reciprocal of cosine, so I'm going to flip the cosine fraction upside down, 2 square root of 5 over 4, and then I'm going to simplify. 2 over 4 is just 1 over 2. Tangent is opposite over adjacent. The opposite side is 2. The adjacent side is 4. So I end up getting 1/2. And of course, cotangent is the reciprocal. So I'm simply going to take the 1/2, since it's nice and simple, and flip it upside down. Cotangent is 2. So I've got my 6 trigonometric ratios. So you should have 6 answers for this, because there's 6 trig functions we'll be working with this trimester. So one other quick thing that we want to review is some special right triangles. So there's 2 special right triangles. You'll want to copy these down somewhere in your notes, or on the back of where your unit circle was on your note sheet, if you don't already have these memorized. But these 2 triangles, the ratios will always be the same no matter what triangle is similar to this triangle. So for instance, the triangle that I've hand drawn there with the 30 degrees and the side that's 10, it's a right triangle. And since it has one angle, we can quickly find the other angle is 60 degrees. And since these triangles are similar, the large triangle drawn and the small triangle that I hand drew, those are similar triangles because they have the same angles. So what we can look for is like a scale factor. And we notice that between the 2 sides, the side labeled 1 and 2, there's a twice as relationship there. So the hypotenuse is twice as long as that leg, that's 1. So now I'm going to use that fact to find that other leg on my small triangle, and that's going to be 5. And I'm going to continue using this relationship. Now I'm going to notice, well, hey, this black triangle, the hand-drawn triangle, is 5 times larger than the other triangle. So I'm going to scale everything up by 5, and that helps me find my final side, because that side has to be 5 square roots of 3. So special right triangles, you're going to use ideas from geometry of scaling things up and proportions. So let's take a look at another situation. This time, the side that's 10 is the side across from 60 degrees. So what I'm going to do is I'm going to set up a proportion using the information I have in the other triangle, in the standard unit triangle, so to speak. So I'm going to call the side that I'm looking for x. I'm going to start by finding x, because it says find the missing sides and angles. And x over 1, because x corresponds to the side that has a 1 on it in the blue triangle. And then that has to equal 10 over square root of 3, because those are the other pairs of sides that I know about these triangles. And they have to be proportional. These triangles are similar. And I just simply solve for x. But notice that it really is x over 1, which is just x. So I'm simply going to make 10 over square root of 3 proper by timesing top and bottom by square root of 3. And the side length I get for x is 10 square root of 3 over 3. Now once I get that side x, the hypotenuse is usually easy to get once you have the legs. I'm going to simply use that 1 to 2 relationship, that this hypotenuse is always twice as long as the side that's next to the 60 degrees, that's adjacent to 60 degrees. So I'm going to use that relationship and scale it up by 2, and it's going to be 20 square root of 3 over 3. So I found the missing sides, and of course I want to find the missing angle, but that should be easy because the triangle has to add to 180, and this is a 30, 60, 90 triangle. So you're going to be using proportions to find missing sides and angles, but what's most important is that you get that triangle memorized that you see down at the bottom here. Make sure you get that triangle memorized. One other fact that you will want to write down is these cofunction identities. So we have these cofunction identities, these 6 relationship. Sine and cosine are cofunctions, and so the following will always be true. The sine of the angle will equal the cosine of 90 degrees minus the angle. The same thing for cosine. Cosine of the angle will equal sine of the angle of the 90 minus the angle. It's sine of 90 minus the angle. So how does this play out? Why does this work? Well, let's take a look at this random triangle. I don't know any of the sides, but I'm going to find the ratio for the sine. The sine of 20 degrees is equal to b over c because that's the opposite over hypotenuse. According to this cofunction identity, the cosine of 90 minus 20 will equal b over c as well. Looking at our picture, we can confirm this because that's really asking for the cosine of 70. And the cosine of 70 is also b over c because it's the adjacent over the hypotenuse, b over c. So we can verify that this is true by drawing a right triangle. So these relationships exist because these angles, theta and 90 minus theta, will be in the same exact right triangle. So these cofunctions exist. Everybody has a cofunction. Everyone has a cofunction, and the cofunction, of course, sine and cosine, cotangent and tangent, cosecant and secant. That's why we put the word co, because they're kind of related. They're like sisters and brothers. So let's put this into action. Sine of 72 will be the same value as cosine of 18, because 90 minus 72 is 18. Cosecant of pi over 3. So we didn't talk about radians yet, but of course it's going to be the same relationship. But now pi over 3, we want to use the value of pi over 2 because that's 90 degrees in radians. And that's a value you'll get memorized real quick here. Pi over 2 is the same as 90 degrees in radians. So now we're going to do pi over 2 minus pi over 3. We're going to elicit our fraction skills and get common denominators, 6 in this case. So pi over 2 turns into 3 pi over 6, and pi over 3 turns into 2 pi over 6. I'm going to subtract and get secant of pi over 6. So these two values are equal, cosecant and secant of the what we call complementary angles, because those two make 90 degrees together. We're going to look at one quick example. We're not going to look at this application example because I think it's just very simple and straightforward. See if you can do it for the free response here. So find the cosine of theta in the picture above and find the free response question. Try to find the height. Notice the bottom length of the shadow is 50 feet. Do your best on these questions. Submit your answers on the Google form and bring your questions into class.